Hi everyone, in this video I'm going to go through some examples of adding and subtracting fractions. This is the second video of a two-part series. In the first video I explained why it's important to make sure that we have a common denominator when we add or subtract fractions. In this video I'm going to discuss some different approaches to problems like these and also look at some more difficult or trickier examples. So let's say we had 1 over 2 plus 3 over 4. In the last video, I described how you could just multiply both the numerator and the denominator of both fractions by the denominator of the other fraction. So in this case, we would have 1 over 2 times 4 over 4, since 4 is the denominator of the second fraction. And we would multiply 3 over 4 by 2 over 2, because 2 is the denominator of the first fraction. Once we work these out, we get 4 over 8 and 6 over 8, and then the idea was that we could add up the numerators. We would leave the denominator as is to get in total 10 over 8, which actually simplifies to 5 over 4 because we can divide the numerator and the denominator by 2. As I discussed in the last video, this approach works because multiplying any fraction or term by 2 over 2 or 4 over 4 or any fraction that has the same denominator and numerator is essentially multiplying that fraction by the number 1. So we're not really changing the value of the fractions here, we're just expressing them in a different way that's easier for us. In this problem, one of our denominators, namely 2, is a factor of the other one, and this gives us an opportunity to use a quicker strategy. So just to review, factors are numbers that divide other numbers without remainder. So in my example here, 2 is a factor of 4 because 4 divided by 2 is equal to 2, or equivalently 2 times 2 is equal to 4. And what we can do then is just multiply 1 over 2 just by 2 over 2. And once we work it out, we would get 1 times 2 is equal to 2, and 2 times 2 is equal to 4. And we get 2 over 4, which is an equivalent fraction to 1 over 2. It has the same value, but now it's the case that it has the denominator of 4. So we have the problem in terms of fractions with the same denominator. We add the numerators up, so 2 plus 3 is equal to 5, and we keep the denominator the same, so in total 5 over 4, which is what we got before. So identifying when one of the denominators is a factor of another gives us a more elegant way of approaching problems like these. So our second example is if we have something like 3 over 4 plus 2 over 6. So neither of our denominators here is a factor of the other. So 4 doesn't divide into 6 without remainder, and same with 6 dividing into 4. One way to handle cases like this is if we think of what we call the least common multiple of our two denominators. So what I mean by the least common multiple is just the smallest number that is divisible by both numbers. And it's really easy to find least common multiples. We just start by writing down the multiples of each number, starting from 1. So for instance, we have 4 times 1 is equal to 4, 4 times 2 is equal to 8, 4 times 3 is equal to 12, and we do a few of those and we can stop and then we switch to the other number. So multiples of 6 are, well, 6 times 1 is 6, 6 times 2 is 12, and we can stop here because we can see here that 12 is a common and actually the smallest common multiple of both 4 and 6. So essentially, 4 times 3 is equal to 12 and 6 times 2 is equal to 12. To work with our equation then, we can write equivalent fractions with the denominator of 12. This will mean multiplying 3 over 4 by 3 over 3, and multiplying 2 over 6 by 2 over 2. Once we work this out, we get 9 over 12 and 4 over 12. Adding this up, we get 13 over 12. So this is a little more elegant than the first approach that I mentioned, that would involve multiplying 3 over 4 by 6 over 6 and 2 over 6 by 4 over 4, which would leave us with, well, 18 over 24 and 8 over 24, which is 26 over 24, which we can reduce down to 13 over 12 if we divided both the numerator and denominator by 2. So we would end up with the same number. It's just a little bit more of a simple process to find the least common multiple first. Alright, so I have 2 more examples that are a little different. Let's take 2 over 6 plus 2 times a plus 6 over 3. So here I've introduced some parentheses and a variable in the numerator of one of our terms. Now for this sum, the first thing to note is that 3 is a factor of 6, since 3 times 2 is equal to 6. So in this case, I can multiply, well, our second fraction by 2 over 2. If I do that, then I get, well, 4 times a plus 6 over 6. So what I'm doing is just treating this problem, which is a little bit more complex because it has a little bit more going on, just exactly the same as our simpler problems, and trying not to let all the different parts get in the way of just the general focus, which is to find that common denominator and that equivalent fraction with a common denominator. So adding them together, I get 2 plus 4 times a plus 6 over 6. Now I can simplify this as little or as much as I need. So if I wanted to simplify, I can open the bracket out first. So I would get 2 plus 4a plus 24 over 6. 2 plus 24 we can add together, so we can get 26 plus 4a over 6. If we divide the numerator and denominator by 2, which is a common factor, well, we can get 13 plus 2a over 3. And it actually follows from our discussions that this is all actually equal to 13 over 3 plus 2a over 3. And this brings us to kind of another aside point. All of these are legitimate expressions of exactly the same value. I remember when I first started learning economics, I was quite lost. I could never get the answer right, and I was so lost that I didn't know whether it was because my answer was incorrect or in fact my answer was correct, but I hadn't expressed the answer in the same way as the textbook or answer sheet. So I didn't appreciate how many ways that I could express a given value, and I was getting very frustrated because I couldn't understand why the answers looked so different to my own. So if you were going through that, I completely sympathize, but it does get better with practice. Okay, the last case is if we had variables in the denominator. So let's say I had 5 over 7 plus 2 over a plus 2. So I'm going to use the approach that I started out with and that I went through in the first video. So just multiplying the numerator and denominator of both terms by the denominator of the other term. So I get 5 over 7 times a plus 2 over a plus 2 plus 2 over a plus 2 times 7 over 7. Opening up all the brackets and multiplying through, I'm going to get 5a plus 10 over 7a plus 14 and 14 over 7a plus 14. This is all equal to 5a plus 10 plus 14 over 7a plus 14, and that's all equal to 5a plus 24 over 7a plus 14. And that's it for that one. I don't think I can make that one any simpler, any more simple than I've presented it there. All right, and that's it. I hope that helped. I know that this trips up a few of my economics students in terms of, either understanding how to deal with problems such as adding and subtracting fractions with different denominators, or even just how to approach these kind of trickier problems. So I hope it did help. If it did help, please like and subscribe. Most of all, though, just have a lovely day or evening.